Hello and welcome to this video. In this video we're going to be solving simultaneous equations where one is linear and one is non-linear. So let's jump straight in. Okay, so here we're told to solve. We've got two equations, x plus y is equal to 3 and then x squared plus y squared is equal to 5. So we're solving this simultaneously. What does that mean? Solve them at the same time, the equations. So how are we going to do that? Well, we need to eliminate one of the variables. How can we do that? Well, if we rearrange this equation, x plus y is equal to 3, as y is equal to 3 minus x. So what have I done there? I've taken x away to move to x to the other side. So I've got y is equal to 3 minus x. Then I can substitute that equation into this one for y. So if I go ahead and do that, I'll have x squared, then I've got plus y squared, but y now is 3 minus x, so it's 3 minus x. Be very careful on this step, make sure that you square this. I've seen people that haven't squared this, and obviously that's wrong. Make sure that you square it because it's y squared. This is just y, 3 minus x is just equal to y. So 3 minus x all squared is y squared, and that's equal to 5. Now we just need to tidy this up a little bit so that we can solve for x. So how do we do that? Well, this is equal to that, so then this is equal to x squared. Then we've got to expand this bracket, so I'll just write this like so. And 3 minus x for that. And that's all equal to 5. Okay, so if I expand this, so I'll get x squared plus 9. Then I get minus 3x minus 3x again. And then the final bit, minus x times minus x, well that's positive x squared, so plus x squared. And that's equal to 5. Okay, so now I can go ahead and tidy this up. So I've got x squared plus x squared, well that's 2x squared. I've got minus 3x minus 3x, so that's minus 6x. So that's sorted that out, and then I've got plus 9. Again, that's all equal to 5. Okay, what can I do from here? Well, as we're going to solve, it would be helpful if our equation was equal to 0. So how can I do that? Well, if I pull that 5 across, so I've got 2x squared minus 6x plus 9. I'm moving the minus 5, so move it to the side, take it away. That's now equal to 0. Okay, so I can go a step further here. So I get 2x squared minus 6x, and then plus 9 take away 5, well that's positive 4. And that's all equal to 0. Okay, sneaky step here. As all of the terms in our equation are a multiple of 2, we can just divide this equation through by 2. So if I do that, so I'm just going to write here, divide by 2, I'll get x squared minus 3x plus 2. Why have I done that? Well, having the coefficient of x squared as 1 is going to make this easier to deal with and solve rather than having 2x squared. Okay, so now I just need to factorize this essentially to get my solutions for x. So how am I going to do that? Remembering that this is all equal to 0. So factorize. So I've got x squared. Okay, what have I got here? Well, I've got 2. What are the factors of 2? Well, only 2 and 1, obviously because 2 is a prime number, so 2 and 1. And how could I get minus 3x? Well, if I take 2 away and take minus 1 away, well, when I expand this, I'll get minus 2x for that. And then for this, I'll get minus x. Minus 2x minus x, well, that's minus 3x. And minus 2 times minus 1, well, that's positive 2. So I'm quite happy that that's factorised. And that's correct. Okay, what do I do from here? Well, I need my solutions for x. So I do this in the usual way. When we're solving quadratic equations, x is now equal to 2. Or x is equal to 1. Okay. So what have we done there? Well, we've solved for x. So we've done all this process of eliminating y so that we can solve for x. So what do I do now? Well, when I solve simultaneous equations, a normal simultaneous equation, I get a solution for x and I get a solution for y. Now I've got 2 solutions for x, so therefore I've got to find 2 solutions for y. So how do I do that? Well, I just substitute the values for x I've got back into the equations. Now, I would always pick the easiest equation in order to do this, so pick x plus y is equal to 3. That's far easier to deal with than x squared plus y squared is equal to 5. So we'll jump in and do that. So when x is 2, well, we substitute 2 in, so in fact I'll just write x is equal to 2. Well, 2 plus y is equal to 3. So y is equal to 3 minus 2. So y there is equal to 1. So when x is 2, y is 1. Okay, what about when x is 1? Well, again, substitute x in, so I'll get 1 plus y, and that's all equal to 3. So just solve that, so I'll get y is equal to 3 minus 1. So y is therefore equal to 2. So therefore, when x is equal to 1, y is equal to 2. So for these questions where we've got one that's a quadratic, we actually get 4 answers. So we get 2 answers for x and we get 2 answers for y, but they're corresponding. So we can't have when x is 2, y is 2. It's when x is 2, y is equal to 1. And when x is equal to 1, y is equal to 2. So in your exam, there'll probably be like a little answer line, obviously, to write your answer. So make sure that you just put the solutions as they are in pairs, you know, corresponding answers. Okay, so how about this question? X plus y is equal to 4, and the equation y squared is equal to 4x plus 5. Well, same step, let's eliminate a variable. So let's try and eliminate y. I think that's always a nice one to eliminate. So we've got x plus y is equal to 4, so I can rearrange that for y as the subject, which leaves me with 4 minus x. Okay, so I can substitute this, I've just found, into this equation. So I'll get 4 minus x. And remember that this is just y. 4 minus x is equal to y, so y squared is that all squared. And that's equal to 4x plus 5. So then I've got 4 minus x times by itself. Like that. So same as before, expand the bracket. So 4 times 4, well that's 16. Minus x times 4, well that's minus 4x. Then for the other one, minus x times 4, that's minus 4x. And then the last part, minus x times minus x, that's positive x squared. And that's equal to 4x plus 5. Okay, what I'm going to do is I'm going to collect some like terms on the left hand side first and rewrite it. So we've got x squared at the start, so that's x squared minus 8x, and that's a positive 16 there, so plus 16 at the end. And that obviously looks more familiar and something that we're a bit more used to seeing. And that's equal to 4x plus 5. Okay, now same as before, I need to get everything on one side so that I can solve it. It wouldn't be wise really here to start moving things to the right hand side, so to start going that way, because if I do that I'm then going to get, well, I have to take this x squared over, so I'll get minus x squared. That's just a bit tricky, so what I would suggest to do is to move everything this way. Keep the positive x squared. If you've got positive x squared, keep it where it is. If not, obviously move the x squared if it's negative. Okay, so doing that, I'll get x squared, so minus 8x, and then I'm taking 4x away, plus 16, and then I've got positive 5x on this right hand side, so if I move it to the left, obviously it becomes negative. And that's all equal to 0. Okay, so tidying then this up, got x squared, minus 8x minus 4x, well that's minus 12x. And then it's plus 16 minus 5, plus 16 minus 5, well that's 11. So I've got x squared minus 12x plus 11 is equal to 0. That to me doesn't look like it's going to factorize, so we're going to need the quadratic formula. So just to recap on that, if you've forgotten, x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. Okay, so for this question, x is equal to, well, minus b here is minus 12, so that will just be positive. So remember that the coefficient of x squared is a, the coefficient of x is b, and then whatever number we have at the end is c. So 12 plus or minus b squared, so that's minus 12 squared, well, minus 12 squared is 144, minus 4 times a times c, well, a here is 1, so it's 4 times 1 times 11, and that's all over 2 times a, and a here is 1, so 2 times 1, which is 2. Okay, therefore it's 12 plus or minus, so sorting the bit inside the square root out, 144, take away minus 4 times 1 times 11, well that's minus 44, all over 2, and that's equal to 12 plus or minus the square root of 100 over 2, which which is then equal to 12 plus or minus 10 over 2. I've just realised that in fact would have factorised, so we didn't need to use the formula, but I'm happy that we did this anyway, just to show you that if you get stuck, obviously you can use the formula. Okay, so we can either have, from this point, x is equal to 12 plus 10 over 22. Well, 12 plus 10 is 22 over 2, which is 11. Or x is equal to 12 minus 10, which is 2, and then 2 over 2, which is, of course, 1. So obviously, if we had factorised this, I've just realised that we could have factorised it. We'd have had x minus 11, x minus 1, which is equal to 0. So obviously, this would have worked because we'd have had minus 11x there. Then for x times minus 1, we'd have had minus x. They would have taken away to give us minus 12x, and obviously minus 11 times minus 1 is positive 11. But never mind. It's a good revision of using the quadratic formula. Okay, so now we've got our solutions for x. So we've got x is equal to 11 or x is equal to 1. So let's look at x is equal to 11 first. So when x is equal to 11, and we'll use this equation here because that's a little bit easier to deal with in my opinion. We've got x plus y is equal to 4, so it will be 11 plus y is equal to 4. So solving that, we get 11 is equal to, y is equal to 4 minus 11. 4 minus 11 is minus 7. So when x is equal to 11, so we get the solution when x is equal to 11, y is equal to minus 7. And then for the other solution, x is equal to 1. Well, substituting that into x plus y is equal to 4, we'll get 1 plus y is equal to 4. So we'll rearrange that. Take 1 away from both sides, and then we'll get y is equal to 3. So then our other solution is when x is equal to 1, y is equal to 3. So there, obviously 4 solutions, 2 pairs, so I'll just outline. So this is one pair here, x is equal to 1 when y is equal to 3. And then this other pair here, x is equal to 11 when y is equal to minus 7. So there are solutions in the red boxes. Okay, so now we have the question y is equal to x squared and y minus 5x is equal to 6, and we're told to solve these pair of equations. So attack the question in exactly the same way, eliminate a variable. I'm here going to eliminate y. It would work obviously if you eliminated x, but I'm just going to do y. So I need this equation in terms of y, so that would be 6 plus 5x. And that's that equation in terms of y. Okay, I can now set x squared equal to 6 plus 5x because they're both of these equations start with y. So therefore x squared is equal to 6 plus 5x. And as we've got a quadratic, we realise that, and from the other questions we've done, we'd kind of want the right hand side to be equal to 0. So we'll do that. So we get x squared, and then moving these terms over, minus 5x minus 6, and now obviously that is all equal to 0. Okay, what do we do from here? Well, this one's a slightly easier one. We haven't had to do much algebraic manipulation. So we just factorize. How do we factorize this? Well, we've got x obviously at the start of each bracket. Okay. How are we going to get minus 6 here and minus 5x? Well, if we have, let's say we have 3 and 2. Well, obviously they will multiply to give us minus 6, but how are we going to take 3 and 2 so we get minus 5x? That's not probably going to work. What other factors of 6 do we know? Well, we know 6 and 1, so let's try that. Well, we could have positive 1 and then 6 there. Let's try that. Well, if we see what happens if we have those numbers in our bracket, we get minus 6x there, and we get plus 1 there. 1x, sorry. So obviously I could try that as x. So x minus 6x, well, that is minus 5x. And then obviously minus 6 times positive 1 is minus 6. So I'm happy that that's factorised. So I'll just write that back in. So that was positive, and that was a negative there. And obviously this is all equal to 0. Okay, so what are my solutions for x? Well, x can be equal to 6, or x can be equal to negative 1. Okay, so now I just need to find the corresponding values of y. So when x is equal to 6, and I'm going to use again this equation, I'm going to have y is equal to, sorry, y minus 5 times x, well x here is 6, that's 5 times 6, that's equal to 6. So that's y minus 30, which is equal to 6. So therefore, add in 30 on to both sides, y is equal to 36. So when x is 6, y is 36. So x is equal to 6, y is equal to 36. Okay, and then when x is equal to negative 1, we get y, and then be careful, obviously here it's minus 5, it's minus 5 times minus 1, so it's minus 5 times minus 1, which is equal to 6. Minus 5 times minus 1 is positive 5, and that's equal to 6. So then, to get y on its own, we've got 6 take away 5, which is of course 1. So when x is equal to minus 1, y is equal to 1. Okay, now I want to talk about, because I haven't really spoken about this, well, what do these solutions mean? It's all very well and good obviously solving these sets of equations, but what do the solutions mean? So to show this, I'm just going to quickly draw an axis. Okay, so I'll just draw that about here. What I'm going to plot on this axis is I'm firstly going to draw, or just do a quick sketch of the graph of y is equal to x squared. What does that look like? Well, it looks something like that. that obviously isn't the world's best drawing, so use your imagination. And then I'll use blue actually now. Then I'm going to plot this equation. So I'll just write it slightly different here. So we've got y is equal to 5x plus 6. So 5x plus 6, well, it's going to cut the y-axis at 6, isn't it, obviously? So, and obviously it's a straight line because it's a linear graph. So let's just assume it looks something like this. Obviously this is a sketch, it's very rough. Okay, so yeah, what do our solutions mean? Well, when we solve normal quadratic equations, it's the point of intersection. So it would seem logical that it's also the point of intersection here, and it is. So just from our sketch we can see that we've got a point of intersection here, so this point here, and then if we look at the solutions that we got, so I'm just going to draw that again, sorry. So if we look at the solutions that we got, we've got one solution that where x is equal to 6, y is equal to 36, so that's obviously that solution there. So that point there is point 6, 36. And then obviously we also have this solution here. Well, we're into our negatives on the x-axis, which makes sense because we've got a negative answer for x, and it's a y value of 1. So this point here is minus 1, 1. Okay, so I've done that really just to highlight that our solutions that we've obtained here are special because they are points of intersection of our lines, and obviously it now becomes clear why we have two pairs of solutions, because there are 2 points of intersection. Obviously it varies for whatever question you're answering, but in this case we've got a point of intersection here and a point of intersection here also. So we're going to see a problem later actually where that knowledge is useful and will help us work something out. Okay, so here we have another problem. X squared plus y squared is equal to 20 and y is equal to x plus 3. So we need to eliminate a variable. So how will we do that? Well, same as we've done for the other questions, we'll just substitute this equation for y into here, so obviously it becomes y squared. So doing that, we get x plus 3. Remember that that's all squared, and that is equal to 20. So then we need to expand this bracket, so we get x squared, and then that's plus this bracket twice, obviously because it's squared. So times by x plus 3. And that's all equal to 20. Okay, so we've got x squared at the start of this equation. And then expanding this bracket out, well, we'll get x times x, which is x squared. 3 times x, which is plus 3x. 3 times x again, which is obviously plus 3x. And then 3 times 3, which is positive 9. And that's all equal to 20. Okay, so what do we do from here? Well, we start collecting like terms. So we've got x squared plus x squared. Well, that's 2x squared. We've got 3x plus 3x. Well, that's 6x. We've got plus 9 at the end. Then obviously we can bring this 20 across, so our equation then is equal to 0. So we've got 9 minus 20, and that's all equal to 0. Okay, so we've got 2x squared plus 6x, and then 9 minus 20, which is of course minus 11, and that's all equal to 0. Now I've deliberately put this question in because it doesn't factorise. This is not going to factorise because 11 is a prime number, so the only factors we've got are 1 and 11. We can't add or subtract those and get the coefficient of x here, which is 6. So for this one we're definitely going to need the quadratic formula. So reminder of what that is. So x is equal to minus b plus or minus square root of b squared minus 4ac, and that's all over 2a. Okay, so what is b here? Well, b is 6, so we start with minus 6, then plus or minus b squared. Well, that's going to be 36 minus 4 times a times c. Well, a here is 2. And c here is minus 11. And that's all over 2a. And a, of course, is 2. So it's all over 2 times 2, which is 4. Okay, sorting out our square root. So we'll have minus 6 plus or minus out the square root of 36 minus 4 times 2 times minus 11. So I'm just going to punch this in on the calculator. So it's 36 minus 4 times 2 times minus 11. So make sure that you type this in right, because if you type it in wrong, we'll have 36 minus 88, and then we're going to have a negative square root, which we can't have. It needs to be positive, and obviously it will be positive because we've got two minuses, so they become a plus. So we get the square root of 124 there. 124, and that's all over 4. Okay, obviously this is going to come out as a decimal because we haven't got a square root of 124. It's most likely going to be 11 point something for that square root there. Okay, so x can be it can be minus 6 and then the positive option. So positive root 124 over 4. That comes out at 1.28. So 1.2838 dot dot dot. Always better to leave a few digits rather than rounding earlier than getting a rounding error later on. So always leave a few digits. Or x can be the other option, so minus 6 minus root 124 over 4. So that can there be equal to minus 4.2838. And so on. So they are our x values, so then we can use those to find the corresponding y values. So we'll do that here. So y is equal to x plus 3, so we'll substitute them into this equation here. And doing that, 1.2838 plus 3. Y comes out there as 4.2838. So you could have done that in your head. And then for the other option, we've got minus 4.2838 plus 3. And that comes out at minus 1.283. 3, 8. So the last thing I'm going to do is I'm going to round my answer to 3 significant figures. So to 3 significant figures. So the one solution, x is 1.28 and y is equal to 4.28. So that's the one set of solutions, and then the other set, x is equal to minus 4.28 and y is equal to minus 1.28. So they're the two solutions, or two sets of solutions I should say. Okay, so we're going to finish the video with this question. This is more of a problem solving type question, and we're told that the lines with the equations y is equal to x squared plus 4 and y is equal to x plus 10 intersect at the points A and B. So that's A and that's B there. M is the midpoint of AB, so M is the midpoint of this line AB. Find the coordinates of M. Okay, so the first thing that we need to do is we need to find the points of intersection, so A and B. How are we going to do that? Well, by solving the equations simultaneously. So we can jump straight in. So we've got y is equal to x squared plus 4 and y is equal to x plus 10. So we can just equate them because they're equal to y. So x squared plus 4, and we can equate that to x plus 10. Keeping in mind what I said earlier in the video, try to keep your x squared positive. So move everything to the left hand side. So we get x squared minus x plus 4 minus 10, and that's obviously now all equal to 0. So tidying that up, we get x squared minus x, and then 4 minus 10, well that's minus 6, and that's equal to 0. Okay, can we factorise this quadratic? Well, let's have a go. So x, and x because the coefficient of x squared is just 1. So how are we going to get the product minus 6 here and then an additional summation to give us minus 1x or minus x? Well, let's try 3 and 2. So if we had positive 2 and a negative 3, well, let's try that. Minus 3 times positive 2, well, that's going to give us minus 6, so we're happy with that. And if we just check the coefficient of x there, so minus 3 times x, well, that's minus 3x. And then x times positive 2, well, that's 2x. Minus 3x plus 2x, well, that's minus x. So we're happy that that is factorised. So that is all equal to 0, of course. And then we get that x is equal to 3, or x is equal to minus 2. And if we just look at our diagram here, well, the points of intersection, one is a positive x and the other is a negative because it's this side, obviously, of the line. X is equal to 0. Okay, so we need to now find our corresponding y values. So we'll use this easier equation. Y is equal to x plus 10. So when x is equal to 3, y is equal to 3 plus 10, so y is equal to 13. So that gives us one solution, which is x is equal to 3, y is equal to 13, and that as a coordinate is the point 3, 13, obviously. Okay, what about when x is equal to negative 2? Well, when x is equal to negative 2, we have that y is equal to minus 2 plus 10 minus 2 plus 10, well, that's equal to 8. So y is equal to 8 there. So then we have the other solution. X is equal to minus 2. Y is equal to 8. So that obviously as a coordinate is minus 2, 8. And then we just check our diagram, and what we've got, we're happy with. Obviously we have no numbers on this equation, but I suppose if we consider the line y is equal to x plus 10, this straight line here, then the y-intercept of that line is 10. So 8, yeah, it seems to be about right, so we're happy with that. Okay, so we're told that M is the midpoint of AB. Find the coordinates of M. How are we going to do that? Well, there is a formula for working out the midpoint, and that is midpoint between two coordinates. That is, we take the first x and the second x, we add them together and divide by 2, and then we take the first y and the second y, so y1 plus y2, and then we divide that by 2, and that will give us the midpoint. In fact, I'm going to change that to an equals because it is equal to that. Okay, so we can take the coordinates we've got and find the midpoint of them. So x1 here, the first x coordinate, that's 3. The second x coordinate, that's minus 2. So 3 plus minus 2, well, that's just minus 2, and that's all over 2. And then we've got the first y coordinate, and that was 13. That's a very dodgy 13. Let me make that better. So 13. And then our second y coordinate, which is 8. So 13 plus 8 divided by 2. Okay. 3 minus 2, that's 1. And 1 divided by 2, that's just a half. And 13 plus 8 is 21. And it's 21 divided by 2. Like so. We can leave the answer as 21 divided by 2 because that fraction obviously won't simplify any further. Or if you obviously so wished, you could write the coordinates as decimals. So you'd have 0.5 and 10.5, right? So those coordinates that we've worked out are the coordinates of M, which is the midpoint of AB. So that's the end of that video. I just wanted to conclude with a bit more of a problem solving type question.